Explore the world of dynamic computation graphs in PyTorch, mastering skills crucial for developing flexible and efficient deep learning models. Learn to build, manipulate, and optimize these graphs for complex AI tasks. Welcome to our exploration of dynamic computation graphs in PyTorch. Did you know that mastering these graphs can significantly enhance your ability to build flexible and efficient AI models? In this video, we'll dive deep into understanding dynamic graphs, their advantages over static graphs, and how they can be manipulated during runtime. We'll also tackle common pitfalls, debugging tips, and real-world applications. By the end of this video, you'll have the skills to leverage dynamic graphs for complex AI tasks, setting you apart in the rapidly evolving field of deep learning. Dynamic computation graphs are a game changer in the world of deep learning, offering unparalleled flexibility and adaptability. Unlike static graphs, which are defined and fixed before runtime, dynamic graphs are constructed on the fly, allowing for changes during execution. This flexibility is particularly beneficial in scenarios requiring varied computations, such as recurrent neural networks or models with varying input sizes. By enabling real-time modifications, dynamic graphs facilitate more efficient debugging and optimization. In this segment, we'll explore how dynamic graphs can be tailored to meet the specific needs of complex AI tasks, offering insights into their advantages over static graphs. Let's roll up our sleeves and create our first dynamic computation graph in PyTorch. Start by understanding PyTorch's AutoGrad, an automatic differentiation system that underpins dynamic graph creation. We'll begin with a simple example, using basic operations to construct a graph dynamically. As you code along, notice how the graph is built as operations are executed, reflecting the flexibility and power of dynamic computation. This hands-on segment is designed to solidify your understanding by guiding you through each step, ensuring you grasp the mechanics behind PyTorch's dynamic graphs. In this segment, we delve into the fascinating world of graph manipulation during runtime. One of the standout features of dynamic graphs is their ability to adapt to changes in real time. We'll explore how to efficiently handle variable input sizes and incorporate control flow elements like loops and conditionals into your graphs. This flexibility allows for dynamic neural network architectures that can adjust according to the data they receive. Through practical examples, you'll learn how to leverage PyTorch's capabilities to modify graphs dynamically, enhancing the adaptability and performance of your models. While dynamic computation graphs offer immense flexibility, they also come with their set of challenges. In this segment, we'll address common pitfalls, such as memory leaks and inefficient graph management. Understanding these issues is crucial for maintaining optimal performance and avoiding potential bottlenecks. We'll explore strategies to handle changing graph topologies and implement best practices to ensure your dynamic graphs remain efficient and error-free. By learning to anticipate and mitigate these challenges, you'll enhance your ability to build robust and effective deep learning models. Integrating dynamic computation graphs with neural networks unlocks a new realm of possibilities for model design and performance optimization. In this segment, we explore how dynamic graphs enhance flexibility in recurrent neural networks, RNNs, and long short-term memory networks, LSTMs, allowing for layers and operations to adjust in response to varying data requirements. Whether you're tackling tasks with diverse input sizes or seeking to optimize model performance, dynamic graphs provide the adaptability needed to succeed. We'll discuss real-world applications and guide you in incorporating these graphs into your neural network architectures. Debugging dynamic computation graphs can be a daunting task, but with the right techniques, you can navigate this challenge with confidence. In this segment, we'll identify common errors that arise in dynamic graphs and introduce tools available in PyTorch to aid in debugging. We'll walk through analyzing error messages, following a step-by-step process to identify and resolve issues effectively. By honing your error handling skills, you'll be better equipped to tackle any challenges that arise, ensuring your dynamic graphs function smoothly and efficiently. Dynamic computation graphs are pivotal in advancing real-world AI applications, offering the flexibility and adaptability needed for cutting-edge tasks. In this segment, we'll explore various use cases, from natural language processing to computer vision, demonstrating how dynamic graphs empower adaptive models. Their ability to handle diverse and evolving data sets makes them invaluable in creating robust and scalable solutions. We'll also look ahead to future trends, examining how dynamic graphs continue to shape the AI landscape, driving innovation and efficiency in complex computational tasks.
Congratulations on mastering the essentials of dynamic computation graphs in PyTorch. We've explored their advantages over static graphs, learned how to create and manipulate them, and examine their role in optimizing neural networks. As you continue your journey, remember to practice and apply these skills to your projects. We'd love for you to join our community by sharing your experiences and insights in the comments. Don't forget to like, share, and subscribe for more content on AI and deep learning. Your engagement helps us grow and deliver more valuable content.